Let's talk about Project 6, Lesson 27. A pattern is made by toothpick squares. Select the series that represents the number of toothpicks added to a picture to get the next picture to the right. Pretend the first picture has no toothpicks. So examine the picture for a moment and we can see what's happening. You see we start with this square. The next image is a larger square, it's a 4 by 4. The next image is a 3 by 3. The next image is a 4 by 4. And we can assume that the next image, if there was one, would be a 5 by 5 square, right? And when I say 3 by 3, 4 by 4, I'm talking about the number of boxes that it takes to create the height and the width, right? So this is a 4 by 4, this is a 3 by 3, this is a 2 by 2, that's a 1 by 1. Okay. Now, here we're not counting the number of squares that comprise each of these images, we're counting toothpicks. Okay, so we'll call these, just going to call each of these like a figure. And I'm going to label them. So I've got figure number 1, which is a 1 by 1, figure 2 is a 2 by 2, figure 3 is a 3 by 3, figure 4 is a 4 by 4. And I also have, going on here, a certain number of toothpicks, right? So I'm going to count the number of toothpicks added to each figure. Now, starting with figure 1, remember that we were told to pretend that the first picture has no toothpicks. So if we go from no toothpicks to 1, 2, 3, 4 toothpicks, that means we've added 4 toothpicks, right? So to go from none to 4, we add 4 toothpicks. Now, not counting the toothpicks that we've already counted, right? We've already counted these 4. I want to count how many toothpicks were added on top of that to get figure 2. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. So they added 8 toothpicks that had not been accounted for. So what about in the next figure? So you notice the green toothpicks are the ones that have been added here. So I count only the green, and I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I see that 12 have been added onto this image. Finally, my last image, I've already accounted for the red, the blue, and the green toothpicks. Now I count my purples. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I've added on 16 toothpicks. Now, based on this information, I am supposed to select the series that represents the number of toothpicks added to the picture to get the next picture. Well, pretty easy to see from the information I've already written that the correct answer is 4 plus 8 plus 12 plus 16, and my rule is a sub n equals 4n. Now I know I actually just gave you the answer to the question, which I always abstain from doing, but in this case, I don't think I was really giving anything away. Pretty easy to determine once I had added up or had counted up how many toothpicks were added to each figure, right? The reason that I wanted to make clear what the answer was is that I want to continue to talk about it as we move into the next question, okay? So what I want you to get from this is just to understand the mechanics of the picture and how everything's being formed. So again, we go from no toothpicks to a 1 by 1 box, and as my figure gets larger, right, from a 1 by 1 to a 2 by 2 to a 3 by 3 to a 4 by 4, I'm adding the number of toothpicks, or I'm counting the number of toothpicks that are added onto it to make that next image. So the rule for that is a sub n equals 4n. Now, the next question asks me to write a series in summation notation for the total number of toothpicks in a square with a side length of 6 toothpicks. So we've got everything up to a 4 by 4. Right, so let's say this is my 4 by 4. 1, 2. All right. So this is what I already have. And the next image, as we know, will be a 5 by 5, right? So my next image would look like this. So that's my 5 by 5. And then to get a 6 by 6, why don't we just even go ahead and draw it? To get a 6 by 6, I have to do something like this. And I'd have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and then I would have to add on, let's see, we'll do light blue. I have to add on here, and I'd have to count the squares I had added. Now, this doesn't necessarily help me answer the question, right? Because even if I know the numbers that I'm adding, I still have to write the series in summation notation, but having these visuals might help us ensure that we're getting the right series. So first of all, summation notation, what does that mean? It means we're going to use this summation symbol, epsilon. This literally means the sum of, okay? Or the sum from, okay? What do I mean by that? So we have this summation symbol. We need to know what we're adding, okay? We need to know what we're adding. So in this case, we already found out in the last question that the rule for this is a sub n equals 4n, right? So from a previous question, where can I write this? I'll say previous. We found out that a sub n equals 4n is the rule for this series. So I need to write this series in summation notation. So summations always start by telling me where I'm going. So I have an index. I have an index from n equals something to something, okay? Now n in this case, n we're going to say is our figure number, okay? N is our figure number, or we could say n is the block length or height, right? So for example, what do I mean by that? So n equals 1 would look like this guy, because this is a 1 by 1 box, and it's also just figure number 1. N equals 2 would be the 2 by 2. N equals 3, here's n equals 4, here's n equals 5, here's n equals 6. So again, you can either think about this as just, okay, I'm numbering the figures as I go, or you can think about it as, there should be a line there. You can think about it as, if I count 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, right? If I count the length or the width, that's the number I get. So they're telling me to take this number for a square with a side length of 6 toothpicks. So if it has 6 toothpicks, that means that n equals 6, okay? Now, I'm writing this summation notation for the total number of toothpicks in a square with a side length of 6. And the way I figure that out is I add together how many toothpicks were added each time to get that figure, okay? So rather than the way this series is built, I'm not going to figure out the number of toothpicks in this 6 by 6 square by simply starting at figure 6 and counting them all. Rather, I start at figure 1, and I count how many were added to make that figure. Then I count how many blue toothpicks were added to get figure 2. Then I count how many green, how many purple, how many yellow were added, how many light blue were added. Okay, so you can see each time I'm just counting how many were added to get the new figure. Now if I add all of those numbers together, if I add the number of red, dark blue, green, purple, yellow, and light blue toothpicks all together, it's going to tell me the total number of toothpicks it takes to build a square with a side length of 6 toothpicks, okay? So I'm taking the sum, I'm adding all of the toothpicks from figure number 1, from n equals 1, to figure number 6, okay? So that's the first part of this notation, just setting up that I'm taking a sum from when n equaled 1 toothpick length, to where n equals 6 toothpick lengths, okay? I know that took a lot of explaining, but once you understand the way the indexes or the indices work, it becomes much more easy. Okay, now what is the next part is, well, what of the n from 1 to 6 of what, okay? And this is where we write in our rule, which we found out in the last lesson was 4n. Okay, so I'm taking the sum from n equals 1 to 6 of 4n. So what does that mean? Let's even work that out a little bit. So, in fact, let me clear some space here. So that means that if I plug in 1 for n, I should get the number of toothpicks added onto the figure to create figure 1. Okay, so I know that it took 1, 2, 3, 4 toothpicks to get figure 1. So that means if I plug in n equals 1, I should get a 4 out of it. Okay, so if I just count from n equals 1 and evaluate this, I'll get 4. So when n equals 1, so how do I want to do this? So for n equals 1, 4 times 1 is 4, right? So you can see I'm building it downwards like this. So I'm evaluating it for n equals 1, so I plug in 1 for n. 4 times 1 is 4. The next piece is n, so I'm going to take that number and I'm going to add it to n equals 2. n equals 2 would be 4 times 2, which is 8, right? And sure enough, 1, 2, 3, 4, 5, 6, 7, 8 is correct. The next one, n equals 3, we had already counted, and we got 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I should get 12 for my answer. So when I do n equal to 3, I take 4 times 3, because my rule here is 4n. 4 times 3 is 12. I'm going to keep going. Next, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And sure enough, when I do 4 times, this is for n equals 4, 4 times 4 is 16, right? Keep going. What if I evaluate this for n equals 5? So n equals 5 would be 4 times 5, which is 20, right? And if I decided to go back and count this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 is correct. And finally, my last one, I'll do this one in white. For n equals 6, I take 4 times 6, which is 24. And if I were to count all the blue toothpicks I've added on, I should get 24. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Oh, and then I didn't draw that line, 23, 24. Okay. So what just happened? I evaluated the summation, just like it told me to, for n equals 1 through 6. But this is a summation, and I haven't done my sum yet. So the point of this is to evaluate for n equals 1 through 6, and then I add all of my pieces together. So if I want to know the total number of toothpicks in this figure, this 6 by 6 figure, I take 4 plus 8 plus 12 plus 16 plus 20 plus 24. So this, the sum of n equals 1, the sum from n equals 1 to 6 of 4n means that I evaluate, I'm just reiterating this one last time, okay? Means that I evaluate this rule for n equals 1, n equals 2, 3, 4, 5, and 6. And I add each piece together. So that means 4 plus 8 plus 12 plus 16 plus 20 plus 24. And that would tell me, if I take that sum, that will tell me the final answer of how many toothpicks it takes to make that, okay? So, you have your summation, and sure enough, our final question, I kind of jumped ahead here. Our final question was how many toothpicks are required to form the large square with 6 toothpicks on a side. So if we already know our rule is from n equals 1 to 6 of 4n, so you need to evaluate this summation. Okay, so I already did the brunt of the work for you in my last example, and the reason I'm kind of giving you more information than I normally do is I just want to make sure that you understand how these summations are constructed and what they mean. I know that this notation is a little weird the first time you see it, but it really wasn't that hard, right? It's just another way of saying like evaluate 4n. 4n equals 1, 2, 3, 4, 5, and 6, right? And then you just add all of your answers together. So again, I know I already worked out the bulk of this in the last problem, but please just go ahead and do it one more time. Make sure you understand what you're doing, and take your total or your answer for this, and once you evaluate this series once you evaluate the series, you will know the number of toothpicks on this 6 by 6 square.